In this session, we're going to talk about units and measurements. Now, this is the introductory part to your physics course. So, we're going to talk about physical quantities, different types of quantities, like as illustrated here. We're also going to talk about prefixes, how you convert units. Then, at the end of this session, we're going to, solve some questions to just familiarize ourselves with how we convert, from one unit of measurement to another. So let's start. So what are the basics? Units. What are units? And what are measurements? But before we talk about units, we're talking about a physical quantity. We're talking about a physical quantity. Now, something that is physical is something that you can see, right? Now, when you're talking about a quantity, it's something that you can measure. That's what this topic is about, something that you can measure. Now, quantities themselves are countable. You can count a quantity. Okay? These ones we're talking about, attributes of a substance. Okay? So now, these quantities, they are going to have what we call numbers. That's where the aspect of measurements come in. These quantities are also going to have what? A unit. A unit. So, in simpler terms, these quantities can just be thought of as amounts. It can be an amount in terms of grams, that is mass. Okay? Quantities also talk about what we call magnitude. Magnitude, we're talking about, the size. In terms of, if you're talking about length, let's say 10 meters length. Okay? So, this can also maybe equate to what we call rates. Rate is also a quantity. If you're talking about maybe kilometers per hour in terms of speed. So, these, are some of the things that we're going to be, talking about. But now, what is a unit and what is a measurement? So, a measurement has just got something to do with what you're measuring, okay? Now, these units are going to be measured. So, a unit in simpler terms is just, a standard quantity that we use to express these measurements, okay? So, why are we, focusing on units? Because they'll help us, communicate measurements in a consistent manner. For example, you can measure length. Okay, now length can be measured in meters in terms of measurement. Length can also be measured in centimeters. The same length can be measured in kilometers. So what you are measuring is going to be, different. You can also measure time. Now, time can be measured in seconds. Time can be measured in, in minutes. Time can be measured in hours. Okay, you can also measure your mass. How can you measure mass? Using different kinds of tools. Yes, you can measure it in kgs, you can measure it in grams. You can also measure your temperature, or the temperature of an environment, or a chemical reaction, or any sort. That temperature can be measured in degrees Celsius. You can measure it in Kelvin. You can also measure it in degrees Fahrenheit. Okay, other things that you might also consider, you can also measure the energy of a substance, or the energy that is being used by a machine, a substance. So you can measure it in joules. So these are some of the things. So units will be used to to try to explain or to talk about what you've measured in terms of which unit you've used. Okay, so that is very, very important for you to understand. So the way we measure these units come in because physics has got laws. Okay, and laws mostly they don't change. Okay, so these laws of physics are expressed in terms of physical quantities, and we've said physical quantities, any quantity that can be measured and will be expressed in form of these laws. Okay, now in order for you to measure a physical quantity, it is its value is usually compared with a standard of the same kind, and that standard is what we call a unit. And we've talked about the magnitude. Now, a unit itself, or let me say a physical quantity, it will have what we call dimensions. Now, dimension, this just talks about, the characteristics of that physical quantity. Okay, it describes the nature of that physical quantity. Example, the dimension of something that you're measuring, you're going to maybe measure its length, you're going to measure its time. Okay, you can even measure its mass. So all these combined, we're talking about dimensions. So this is very, very important for you to understand. Now, what are some of the types of quantities that you are supposed to know? Okay, so there's what we call a scalar quantity. There's what we call a vector quantity. We have what we call fundamental quantities. Which is our lesson of today. Then we're also going to talk about what we call derived quantities. Then lastly, the same physical quantities that we've just talked about. It's another form of quantities that you can measure. Okay, so let's start with physical quantities themselves. So what is a physical quantity? Earlier we said these are quantities with a specific unit of measurement. Okay, so something that you can measure and something that you can see is a physical quantity. So now we're talking about physical quantities with units, because this topic is about units and measurements. There are things that you can see, but they cannot be expressed in terms of units. Okay, or there are certain calculations that you can do, but they will not give you units. For example, a ratio. Okay, for example, maybe you're finding refractive index, you're finding your efficiency, maybe you're finding the percentage of something, the relative humidity. Something that is relative mostly doesn't have a unit, but in this session we're talking about physical quantities with units. Okay, so physical quantities that you can measure, things like length we've talked about. Okay, you can measure it in meters, in terms of foot or feet. You can measure time. Okay, you can measure force. These are things that you can see. Okay, so these are types of physical quantities that you're supposed to understand. Then you also have to understand what we call fundamental quantities. Now, fundamental quantities themselves, these ones are also called basic quantities, or others will call them base quantities. Now, what are these? These will be quantities that cannot be expressed in terms of other quantities. What do we mean? They are independent. They are independent of other quantities. Quantities like length, quantities like time, quantities like mass. Okay, these, they are independent. They don't need other units for them to be are found like that. So that is very, very important for you to know. We're going to talk more about that. Then another type of quantity that you're supposed to know is what we call derived quantities. Now, derived quantities will be those quantities that can be expressed in terms of other quantities. Other quantities, we're talking about fundamental quantities, because something that is fundamental is something that is basic, is something that you are starting with. Even the name itself, derived to mean you are getting these quantities from somewhere. Okay, so for example, if you're finding the area of a substance, now you cannot find area just direct like that. You're going to need other quantities for you to find it. You're going to maybe need the length of the object that you're trying to find the area for. You're going to multiply it with the width. Okay, or what we call LW if it's just an object like that. For example, you can also find the volume. Now, the way you're going to find volume, it will not just be a single straightforward answer, Probably if you are finding the volume of, let me say, a cube, you're just going to multiply the length 3 times L times L times L. Maybe let's say something that has maybe the length and it has a length, the width, let's say, and the height. So you're going to find you are going to multiply the length times the height times the width. Okay, then you can also find speed as a derived quantity. Now you're not just going to find speed directly, you're going to speed is equals to distance over your time. Okay, so these are what we call derived quantities. Then lastly, we've got what we call, not really the last one, but we also have what we call scalar quantities. Now scalar quantities, they are going to be those quantities that have only magnitude. Okay, so what I'm talking about as magnitude refers to the amount, magnitude refers to the size. Okay, so they only have magnitude. For example, temperature. A temperature, let me say maybe a temperature of 20 degrees. Okay, for example, a mass, an example you can say, let's say 5 kg. Okay, for example, you can talk about energy dissipated by an object or a machine. Probably you can just say that is 100 joules. So these are scalar quantities, they only have magnitude. Then lastly, we're going to talk about vector quantities. Now in this session, since this is the introductory part, we're going to explore vectors and scalar quantities in other sessions. Now, what are vector quantities themselves? Vector quantities will be those quantities that will have both magnitude and direction. Okay, unlike scalar quantities which have only, let's say, the magnitude, these ones, they are going to have a direction attached to it. For example, you're talking about displacement. Now, just to explain scalar and vector quantities, just for this session. So distance itself is a scalar quantity. Displacement is a vector quantity. What is distance? Let's say this person has moved from there to there to there, they are moving like that. That would be the distance, not considering the direction. Okay, but for displacement, you're just going to get a straight line like that, going direct to where you're going. So of course, considering the direction in which you are going. So that is a major difference that you're supposed to understand. So like for displacement, an example that you can give, let's say you're moving 10 meters, you've moved 10 meters, we can say you moved 10 meters east. Okay, there is direction attached to it. You can also, velocity is also another, type of a vector quantity. As we'll be talking about, motion. An example that you can give, let's say the velocity can be maybe 50 kilometer per hour, in which direction? Maybe let's say north. Okay, so another example that you can talk about, of a vector quantity, you can talk about force. Let's say this person moved, or let me say you pushed this object 10 newtons upward. Okay, that would be a force. Or let's say you're in an elevator, you are standing and the elevator is pushing you upward. Okay, but you also have your weight. Your weight is also going in this direction, and a lot of forces will be acting on you. So we're going to talk about forces, in other sessions. So this is very, very important, for you to know. Now we introduce the aspect of what we call physical quantities. But now the way these physical quantities are going to be considered is that you're going to estimate physical quantities. How you estimate them? probably you are going to be rounding them, or what we call rounded numbers. Then you can also, estimate them based on maybe a certain reference point. Okay, what we call a benchmark mark. Okay, then you can also maybe consider it. You can also approximate them. So these are the three estimations that we are going to use for physical quantities. Okay, I just thought of passing that through. Now, they are what we call prefixes. Now, this is very, very important for you to know. When we're talking about prefixes, these ones will be, a group of letters or symbols that will be added at the beginning of, let me say, a quantity to magnify it, to magnify its meaning. So, there is what we call a suffix and a prefix. Let me just try to, write the two. So prefix, pre to mean before. So it means it's going to come before the word to magnify what you're talking about. Okay. A suffix, on the other hand, it will be at the end of, let me say, a word or a quantity that you're talking about. So now, prefixes themselves, in terms of, in the context of, measurements and units, they'll be used to indicate what we call decimal, multiples, and submultiples. And what we call submultiples. So, multiples, in this case, what we're referring to quantities that are larger than the base unit. So, quantities that will be larger than the base unit, that's what we are calling as multiples. So these ones are larger. Submultiples, these ones, they are smaller than the base unit. Now, this is very, very important for you to know. Then, before we come up with a table about multiples and submultiples, let's go to fundamental quantities. Now, to understand prefixes, let's first talk about fundamental quantities. Now, there are about 7 base units according to the International System, of Units. International System of Units, the ISU. Okay, so they came up with 7 basic, or let me say, base units. So to explain this, let me use a table. We can say this is a quantity. We can say this is the name of that quantity. We can say this is a symbol of that quantity. Okay. We can talk about, let's start with the first one. The first one that we can talk about is what? Length. Now, length is measured in meters. Okay, the symbol for meters is just, M like that. Now, a meter, according to after they sat and came up with, these units, they defined the meter as the distance traveled by light in a vacuum during a specific time of interval. Now, note, we're talking about this distance traveled by light. Let's say this is a vacuum space, and light is traveling in this vacuum space over a specific period of time. That's what they defined as a meter according to the international, that's the ISU. Then another base quantity that you're supposed to understand is what we call mass. Now, mass is measured in kilograms. The symbol is just kg. Okay, so the way they define mass currently according to the ISU is that mass, I know other mass is a measure of the amount of a substance, right? But a kilogram itself, the way they measured the kilogram was based on a specific definition or what they called a platinum iridium alloy. Now an alloy is just a combination of two let me say metals. So they defined a kilogram or a kg as a specific platinum iridium alloy or cylinders that they kept at the same international bureau of weights and measures. This was in France. So that is very, very important for you to know. Then another base quantity that you're supposed to know is what we call time. Now time is measured using watches, a lot of things, but now time is measured in seconds. Now what is a second according to the international system of units? They define the second based on the vibration of what we call cesium atoms or cesium, whatever, but this name. So they defined a second based on the vibration of the cesium atoms. That's how they're able to come up with the seconds. Okay, then another thing that you're supposed to understand in terms of base quantities is what we call electric current. So I've specified electric current. This is not any other current but current due to flow of electrons. So they measure current or electric current in terms of ampere or ampere. The symbol, it is just A. So they defined an ampere based on the force between two current carrying conductors. So if I've got a conductor, a conductor is just a material that allows electricity to pass through. In this case, we're talking about an electrode. Okay, so an electrode allows electrons to pass through from one terminal to the other terminal. So they defined an ampere based on the force that acts between two carrying current carrying conductors. So that's electric current. Then another base quantity that you're supposed to understand is an amount of a substance. Now an amount of a substance, you measure it in terms of moles. Okay, a mole. Then the symbol that you are going to use for a mole is just M or L. So what is a mole? A mole, we're just talking about the amount of a substance that contains the same number of entities as there are atoms in the 12 grams of carbon 12. So that's how they defined a mole. So you compare, the reference point is earlier we said the way you estimate physical quantities, probably you're using 1, you're rounding them to a certain number. 2, you're approximating them. 3, you're using a benchmark or what we call a reference point. So they measure this a mole in terms of you're comparing to carbon 12. Now that will be talked about under stoichiometry. But why are we choosing carbon 12? Because number one is that carbon 12 is abundant. You don't want to use because there are a lot of elements that you can talk about. So which one are you going to be using as a reference point? Probably you choose the one that is most abundant, right? So that in as much as you are carrying an experiment, you can easily get that carbon from anywhere. Carbon is found in a lot of objects, in coal, in a lot of things. That's why of that is used as a reference point. Then lastly, there's what we call luminous intensity. So what about luminous intensity? The name just same, luminous. Something that illuminates is something that gives out light. So about luminous intensity, the name that we use for the way we measure it, we measure it in units called candela. Now candela is just abbreviated as, or the symbol is CD. So they defined a candela in terms of the brightness of a specific type of green light that was being emitted by a cesium atom, or what we call a cesium metal. So a green light was being emitted, you know, from this metal, and they were able now to determine, like, okay, this is, you know, the light. So these are the basic, you know, fundamental quantities that you're supposed to understand. And it's from these you know, quantities that are your derived quantities are going to be coming from, because derived just means that's where you're getting them from. So these will be basic quantities that you're supposed to understand. Now, not only these are the quantities that you can use, we also have got what we call prefixes. Now, I was about to come up with like a table just to explain on prefixes. We said multiples are larger than a certain quantity, submultiples are smaller than a certain quantity. Okay, so let's talk about some of the examples that we can talk about here. Okay, so prefixes, they'll just be a convenient way to deal with very small numbers, or sometimes even very big numbers. That's why we use prefixes. But mostly for big numbers, we're going to use mostly, you know, scientific notation. Okay, that's what we're going to use. So what are some of the common prefixes? Let's start with multiples. So you're multiplying these quantities with a 10. Okay, so the first one, let's say, is called the deca. The second one is called the hecta. The third one is called the kilo. You're going to talk about a mega, you know, a giga, a tera, and you'll be going like that. But these are the common ones that you're going to be using mostly, you know, in physics. So the prefix deca, or let me say in terms of numbers, let's put numbers first. Deca just means 10, right? Okay, deca means 10. Hecta means 100, right? So we can write it as 10 to the power 2. Kilo means 1,000, so that is 10 to the power 3. Mega means 1,000,000, okay? So that is 10 to the power 6. Giga will mean 1,000,000,000. That would be 10 to the power 9. Then you have tera, which is 10 to the power 12. The symbols for these ones, a deca is just the same as DA. A hecta is just the same as a capital letter H, a small letter H actually. A kilo itself is just, you know, in terms, it's just a K. A mega is just a capital letter M. A giga is just a big, you know, a G, a big letter G. Then, and a tera is just a capital letter T. Now the ones I've highlighted in blue, these ones are commonly used, you know, in physics. So you have to understand them and you have to know them, okay, in and out. Then on the other hand, we've got what we call, you know, submultiples. These ones, we said, they reduce the quantity, okay, if you put them in front. Okay, so we've got, you know, we've got submultiples like starting from the smallest one, we can talk about deci, you can talk about centi, you're talking about milli, you're talking about micro, you're talking about nano, you're talking about pico. You can be going on, and you're talking about femto. These are some of them. But now, what is a deci? To be opposite of a deca. So that is just like a 10, but in this case it's like a 0.1. But a 0.1, how are you going to write it? It is 10 to the power negative 1. A centi, okay, a centi will just be 10 to the power negative 2. A milli will be 10 to the power negative 3. A micro will be 10 to the power negative 6. A nano is going to be 10 to the power negative 9. A pico will be 10 to the power negative 12. A femto will be 10 to the power negative 15. You're able to see that mostly the difference between these ones, starting from the second, the difference between them mostly will be a 3. Okay, so because you're adding these thousands and thousands to each of these ones, so these are very important, for you to know, because they'll be used to convert from one unit to another based on what they've given you in front, or to modify the meaning of a quantity. Okay, so I've also talked about scientific notation. Now, just expressing a quantity in scientific notation, mostly it's not that complicated. Okay, maybe let's give an example. Let's say you have a force. Okay, let's say you have a force of 1.23 times, let's say, 10 to the power 6. The way I've expressed it like this, I've expressed this because 10 to the power 6 is a very big number. So instead of me writing all the zeros, probably the number was 1.2, let me say 1, 2, 3, then 1, 2, 3, 4.0. Probably the point moved 1, 2, 3, 4, 5, 6. So when the point moves 6 times, I can write this same number as 1.23 times 10 to the power 6, because there are 6 zeros, or the point has moved 6 steps. That's about scientific notation. For very big numbers, you can express them like that. But now what we've written also can be expressed in terms of prefixes. Okay, since this is a force, let me say it's 1.23 times 10 to the power 6. Let's say it's a Newton, because it's a force. So how are you going to write it in terms of prefixes? This is also the same as 1.23. Now 10 to the power 6, we said it's the same as a mega. So this just equates to meganewtons. That's in words, but if you are expressing in terms of units, you're just going to write 1.23. Mega, we said you're using a capital letter M. Then newtons is just capital letter N. So that's how you're going to express this one. Another example, maybe let's say you're considering a particular time interval. Let's say you have 1.23 times, let's say 10 to the power negative 9 seconds. So because this is time, in terms of prefixes, how are you going to write it? You're going to write it as 1.23. Now 10 to the power negative 9, we've said it is a nano, so this is 1.23 nanoseconds. Now in terms of units, you're just going to write it as 1.23. Now nano, we said just a capital letter N, then seconds just a small letter S. So this is what you're supposed to know. So that is very, very important for you to understand. Now that we've talked about this, let's solve some questions. So you should be able to convert from one unit of measurement to another. That is very, very important. So let's say you're converting, let's say micro liters let's say you're converting them to millimeter cubed. So how are you going to solve that one? Now micro itself, we're saying it is just the same as 1 to the power negative 6, but here this is just a conversion unit on its own. Micro is just the same as 1 microliter. This is how you're going to represent it. This is equals to 1 millimeter cubed. So this is just what is there. You just have to know this conversion unit. Let's solve another one. What if you are given 4.5, let's say times 10 to the power 3, let's say kg per, let's say, meter cubed. You are asked to convert it to, let's say, gram per centimeter cubed. How are you going to convert this unit? So you have to, be very, very conversant. So the unit that we have kg per meter cubed. We are converting it to grams per centimeter cubed. So you have to be able to convert kilograms to grams. Then secondly, we are supposed to convert meter cubed to centimeter cubed. So what are we going to do in this case? So to convert, you know that 1 kg is just 1 kg is just equals to 1,000 grams. Then what about centimeters? Now for centimeters and meters, how are you going to find that one? You know that 1 meter is just equals to 100 centimeters. Then what if we square the meter? 1 meter squared will mean we are multiplying 100 by 100 in terms of centimeters. So this will just be 10,000 centimeter squared. Now when you find, let's say, 1 meter cubed, now it means we are multiplying 100 by itself 3 times. So that what is that going to give us? Okay, so I'm going to have okay, so 100 3 times. That gives us like 1 million. Okay, so this will be a conversion unit for what is down. Okay, now that we've got everything that we need, we have our conversion factors. How do we now solve this one? So you're going to get your 4.5. Your 4.5. Now 4.5, we've said this is 10 to the power 3. This is in scientific notation. But if you want, you can take it back to the way it was. You know that initially, before a point, it was just 4,000. 4,500. Why? That's how it was initially. But when you wanted to express it in scientific notation, it means you move the point 1, 2, 3, making it 4.5 times 10 to the power negative 3. So I'll just write it like that, 4,500. So it's the same thing. We are saying this is kg per meter cubed. So how are you going to convert it? You know that 1 kg, we've said 1 kg is just equals to 1,000 gram. That is our conversion factor. What about for this one? We've said the conversion factor is 1 meter cubed is equals to 1 million centimeter cubed. So that is what we have. Now how do we solve this? How we solve that now is we're just going to be cancelling what is common on both sides. So a kg and a kg can divide, a meter cubed and a meter cubed can divide. Then we solve with whatever we have. Okay, now I've got 3 zeros. I can cancel these 3 zeros. I can also cancel these 3 zeros. Okay, now what have I remained with on top? On top I've remained with a 4,500. There's a gram here. I'm going to write that gram over. We've remained with 1,000 down, so I'm going to write my 1,000. Then I've got a centimeter cubed like that. Then what do I have? I can cancel these 2 zeros. I can cancel these 2 zeros and also cancel 2. So we're dividing 45 by 10. 45 by 10, you know that just gives us 4.5. What are the units? Gram per centimeter cubed. We would have converted to this unit. So that is very important for you to know, to be able to convert from one unit of measurement to another. Let's have another one. What if we say you are told to convert let's say 22 meters per square seconds. You are told to convert it to, let's say, kilometers per minute squared. Okay, so how are you going to solve that one? Okay, so you get to 22 meters. This one was just going to go direct, second squared, times, what is the conversion unit from meters to minutes? Okay, you know that 1 second, or let me say 1 minute, is equals to 60 seconds. What if you square it? 1 minute squared. 1 minute squared will mean 60 times 60. Now 60 times 60, 0 and 0, I'm just going to write that 6 times 6, that's like 36. So in terms of seconds, 1 minute squared is just equals to 3600 second squared. Okay, that is a conversion, factor. What about kilometers? We're converting meters to kilometers, meters to kilometers, like that. So what is a conversion unit? You know that 1 kilometer is equals to 1000 meters, because a kilo means 1000. Okay, so that is a conversion factor. So now that we've got everything, we just have to replace indefinitely. Okay, so we are saying 1 minute squared is equals to 3600, or 60 squared. Okay, seconds squared, multiplied by, we are saying, what about in meters? We are saying 1000 meters is the same as 1 kilometer. So these are the conversion factor. So you have to make sure that the way you're arranging these ones, you're trying to cancel what you have. Okay, the way you're arranging this one and this one, you're trying to divide them. Okay, so that is the approach that we use. So the meter and the meter can divide, the second squared and the second squared can also divide. Then what do we have? When we multiply what we have on top, what do we have? Okay, let me just do everything. 22 multiplied by 3600 divided by 1000, that gives me 79.2. now on top we've got a kilometer, so this will be kilometers per minute squared. So that's how you convert these units. So not very complicated, not very let me say complicated. Let's solve another example. What if you are converting, let's say you're converting 1 day to seconds. 1 day in terms of seconds. What is 1 day in terms of seconds? So what will be our conversion factor? You know that 1 day is equals to how many hours? 24 hours. Okay, 1 hour itself is equals to how many minutes? 60 minutes. 1 minute, you know that is just equals to 60 seconds. So now that we've reached to seconds, the conversion factor, it means you're going to now, for you to come to seconds, you're going to, in terms of seconds, 1 day in terms of seconds, you're going to multiply 24, multiply by 60, multiply by 60. Okay, when I use my calculator, 24 multiplied by 60 multiplied by 60, that gives me 864 86,400 seconds. So that's how you are going to convert, you know, from that to that. Okay, let's make another question. Let's say you're converting 150 micrograms per, okay, let me just write this one nicely, micrograms per mil, okay, let me make it interesting. Micrograms per, let me say 2.5 mil. You want to convert this one to, let's say, gigaliter. How are you going to do that? So very straightforward. Get your 150. We've got micrograms as the denominator, divided by, we've got a 2.5 mil. So what is the conversion factor? Let's start with the mil, or 1 milliliter in terms of liters, because we want to get a liter. Want a milliliter to give us a liter. So what is the conversion unit? So you know that 1 milliliter is just equals to, now the way you write this one, you know that milli means 10 to the power negative 3. So just write 10 to the power negative 3. Then write your liters like that. Liter. You would have, that's the conversion factor. So let's come to the other one. We want to convert micrograms to grams. So how are you going to do that? So which one are we considering? We want this one to go. So now, because we want this one to go, we are going to write it down. 1 microgram. In terms of grams, micro, what does micro mean? That's the question. So you know that micro means 10 to the power negative 6. So we're going to write 10 to the power negative 6. There's a g that has remained grams. So that is the conversion factor. Then whatever you have, it starts to now cancel, divide, and you know, multiply. So the mil and the milliliter, or the mil and the milliliters, they're going to cancel. The microgram and the microgram, they're going to cancel. So now whatever we have, we just have to solve. On top, I've got 150 multiplied by 10 to the power negative 6. Okay, you know that the point is just going to move. So I'm going to have 1.5 times 10 to the power negative 4 grams on top, divided by, I've remained with a 2.5 multiplying by 10 to the power negative 3. Okay, that is 2.5 times 10 to the power negative 3 liters. Then when I do the math, 1.5 times 10 to the power negative 4 divided by 2.5 times 10 to the power negative 3 liters. Okay, I'm getting 0.06, you know, grams per liter. So that's how you're going to solve, you know, this question. So that's, you know, all about, you know, units and conversions. A very simple and very good introduction to physics. So from now on, we're going to now build up from this concept that we've talked about. Okay, so see you in the next session.